Hello, welcome at Mobile World Congress 2026. I'm Michael Dieudonné from Keysight Technologies. I'm an R&D manager in CG Research. Today I will introduce you to our demo related to CSI compression, which is in fact built on a setup that allows you to create, generate, and analyze data to use for your 6G AI physical layer. The setup is composed of an MTRX, which is in this case has 32 ports equivalent to 32 antenna coming from the base station that is then connected, cable conducted to our prop sim, which is the channel emulator. The channel emulator will emulate the air between the transmit antenna and the receive antenna, which is then back to this platform. In this configuration, we are demonstrating 32 antenna transmit and 4 antenna receive. So 32 downlink towards 4 antenna at your UE sites. In this project, this was a collaboration in a project called CG Sandbox from the SNSJU, together with a Centric project, where we have been collaborating with Nokia. In our case as Keysight, we have been providing the platform to generate the data such that Nokia can train their model on the AI physical layer. The problem we're trying to solve here is related to CSI compression. CSI is the report the UE has to send back to the base station about the channel, how you perceive the channel. Whether you are in a tunnel or another location, the CSI will change and the channel state will change. Now you understand when you have one antenna to one antenna, the CSI is a simple report. But if you start talking about higher order MIMO or massive MIMO, the quantity of antenna to report on start to increase dramatically. In this case, we have 32 antennas, so 32 reports that you need to provide. Now there, 3GPP works on compression to simplify the overheads so that you have good quality transmission with lower overheads. And this is where Nokia comes in. Nokia uses our system to generate the data and to analyze the data to train their AI capabilities. And they have developed the CSI compression model. I will hand over you to Amir from Nokia to tell you more about the model.
Hello, I'm Amir Amarian Tehrani from Nokia. In this work, as mentioned by Michael, we have been doing this collaboration on testing how, when it comes to having AI-enabled CSI compression in order to reduce and compress the channel state information, which is exchanged between the UE and base station, in order to find out that how much we can gain, how much we can compress the data between the UE and base station on one hand, and on the other hand, to keep the degradation of the performance due to this compression of the huge size data between the UE and base station on the other hand. And to do that, we have developed a so-called two-sided model, two-sided AI model at Nokia, in which one model is running at the UE and the other model is running at the base station. We start with compressing the CSI and then sending the feedback to the base station, and then we have another model which is running at the base station, so-called decoder, and basically then the base station will be able to somehow reconstruct those data which are actually have not been sent from the UE in a way that will be figure out how to serve the other users in the same frequency domain, scheduling at the same time. So when it comes to comparing and when it comes to comparing the model performance, we have been able to actually beat the existing so-called E-Type 2 CSI feedback, which is now being used in standard, by a factor of more or less 5 in terms of the effective CSI compression rate, meaning that we are able to send 1/5 less number of bits at the same time, and even outperforming the existing approaches, which I just mentioned, this E-Type 2 on the other hand, which has been used now in the standard. So and by doing that, we have verified and validated what has been standardized in 3GPP, and what we are contributing to standard in this hardware in the loop setup, which through a live demo at Mobile World Congress 2026.